I'm going to get started. Here is the project for today. This is coming out of the RPG simulator still, but in a very different way than the RPG simulator rewrite that I've been doing. I'm actually going back into the old code today from my first like 6 week, I don't know if you call it jam or rush on this idea that I was playing with. But within that, I also wrote this other thing, which we haven't really looked at yet, which is these ASCII diagrams that I started making. And they're not too sophisticated yet, and they had some problems the way I did them the first time, but I've had some time to think about how it worked out and what needs to be done. And now I'm going to attempt to do it better. There are a few layers here that I can work on. So um, just to be clear, my goal is to put this straight into my main code base, right? Basically at the same level as my base layer. So right now, my base layer comes with this little expansion called Mr. Fourth Base.standardio.h or stdio.h. And that's the header that you include if you want to include, like, if you're already going to rely on standardio.h, you can include this, and it includes my wrappers. And the reason I like to have wrappers is because, well, it's not there. I think it's in base.c, m4 printf. Right, so the reason I like to have the wrappers is because I can do things like, most importantly, the reason I'm using the wrappers is because I'm using a non-standard. I'm not using the standard library that came with my compiler. I'm using the where is it though? Printf. That's F, right? Print. Oh, okay. So it's been a little while since I looked at this. That's right. What's happening here is, since I don't go through the main one, first of all, it's all going through my string printing one. So instead of using the format strings just to send stuff out to the console, I've made my code base centered around the idea that we're using the same format strings that C had, but we use them to construct strings on the fly so we can use them as data in our programs. And then what I'm doing is I'm using the where is this VSN printf? Where is that? That must not exist. So I think what must be happening is, yeah. So here's what I was looking for. I'm using my own, like I've copied this stbsprintf.h file right into my base header. Like a little bit of viral DNA injected into another organism or something. It's just here. I put a little to-do list with about my base layer, and there's also this list, this inventory for managing the allocation of print symbols to behaviors. The big one is that I've got the string 8, so my length-based string can be printed with a capital S. Hold on. Okay. So the main one is that the string 8, my length-based string, can be printed with a capital S format specifier. I also threw in, there was one or two that were from STB. I think this is from STB code. This is a non-standard modification, which I think is cool. But I also have this one, N, for writing in indentations. So if I want to say indent some text like 5 spaces, I can just do %n and then I pass in a 5, and that generates 5 spaces. So I can generate a variable number of spaces anywhere using the n specifier. I call it indentation because I mostly use that for setting up indentation at the beginning of lines, right? Okay, so The cool thing is now I've got that, expansion, those extra features that I like to use built in. I put those into the code that runs things like constructing the strings, and then if I actually want to print out, if I want to use something like printf, the annoying thing was I used to have to write code like this. I used to have to go printf percent dot star s, and then I'd have to pass it, I'd do something like straight expand string, and then I'd go string h string equals straight push f, right? And then you do scratch arena, and then whatever format string you actually wanted to do, my real percent s percent n indent modifier noun whatever, right? Wherever those come from, who knows, doesn't matter, it's just an example. And so this is how I would do it. Of course, you'd also got to throw in the scratch then, right? So you can see that the minimum amount of code it took to print a format string using my extensions to the format specifiers was really annoying, right? Because my base, the kernel, the thing that basically is the access point to my format string, is straight push F. And so whenever I would start up a little project, it would be really annoying, and I'd have to do this until I got sick of it. And then one day I added these to my base layer, so if I want to, I can just now say all of that is now just m4 printf, grab the format string. So now it just works like printf used to work. Same basic idea, except it uses the Mr. Fourth layer extensions to the printf, which are extensions implemented as modifications to the STB printf. Is it sprintf? Yeah, the STB sprintf. That I just have a copy of sitting in my base layer header. So that's the state of things. And then when I was working on the RPG simulator, I was finding I wanted to lay out like various types of ASCII diagrams a lot. I wanted to see histograms of things, and I also wanted to lay things out into tables. And there are actually a couple different variations of histograms that went through the project that I didn't end up having them all, like they don't all exist anymore, but none of them were exactly right. They were all kind of me not thinking too hard or careful about how the data was being represented. And so I need to think a little bit more carefully about data visualization in ASCII as I'm doing something like a histogram. And then the table is just a layout algorithm, basically. It just keeps all the columns the same width so that you can make a table and it'll actually work no matter how wide your strings are. And so you don't have to, it automates the process of fixing that later. So you stick a bunch of strings into a table data structure and then it figures out columns for you so that you don't have to look ahead and figure out your columns before you start laying things out, or before you start putting the data into the data structure or printing things out or whatever, right? But none of these APIs are particularly well built yet. So even if this is the basic idea is right, there's just no refinement here. And there are some other things that are just not even showing up as code, as function names. Like I didn't end up finding vocabulary for what it was I was building at certain moments. But there are more ideas like the sort of whisker diagrams and other I mean, I'm not going to go into more complex directions. There's another kind of data structure that you could want to visualize it for, which is a graph. And I know if my friend Yasser was here, he'd be interested in an ASCII diagramming directed graph system. But I'm not going that far. I'm not. I don't have that data structure right now. I actually might someday, and so maybe then I'll work on it. But right now, I don't have that data structure to visualize. The main things that I want to visualize are just sort of matrices of results from various combinations of trials and histograms and tables of numbers, like matrices of numbers and stuff like that. So histogram, table, and a few other histogram-like things are pretty much it for now. But I think it's gonna be kind of cool to have somewhere in my code base where I've got advanced printing tools. And so the first thing I want to figure out today is where would I put those. Um, I could put them in here. These are my standard I/O extensions. The upside to that is that they kind of feel like they belong, right? It's more stuff about printing. Some downsides are this is meant to be a small wrapper right now. You can see if I go to Mr. Fourth Base C, these are kind of placed inside of a compilation section here, and it may not be that I want to make this super large, right? I might not want to have to put too much stuff into the M4 printf sections. Which another reason that I want that is if this gets to be large, whenever I have a large amount of code to deal with, I don't like having mismatches. I like one-to-one header C file naming. It's good for organizing and keeping track of where everything is, and also it plays nicely with the four-coder buttons for doing this, which takes you to the matching file if they have the right naming scheme. So I'd kind of like to be able to stick in that level, like that level of significance for this kind of stuff. And at the same time, it might be nice to have some of these APIs. I don't know. Let's do that though, because that'll also give me a space to write down the rest of my to-dos, and I think that that's just the right place to start. So we're gonna do Mr. Fourth ASCII.h, Mr. Fourth ASCII.c. So this will be a new layer. Why isn't this project loaded? I might have restarted four-coder sometime earlier today and forgot about it. Okay, now PRNG. Let's see here. I'm gonna just keep copying this because I was part of the way through a plan earlier like it was a little while ago, like 6 or 10 months ago, to set this base layer up to a new level, kind of level it up and get it out to people. And I didn't do the get it out to people part. I bounced around to other projects. But I still want to do that, and so some of this stuff was an incomplete plan to organize everything. And sticking with it might give me the benefit of being able to just pick up where I left off when I do get ready to go back to working on it. Okay. Now I'm ripping this from the old simulation system for now. Just to get me started. Let's see. function has to get replaced with Mr. Fourth symbol. Let's see here. Yeah, that might not be the full API that I want when I'm done redesigning it. So let me think. I think the first big thing I'm noticing is this is assuming directly printing to standard out. And I want to stick to the rule of my system a little better. Now, that does raise another thing, which is at some point here I have a to-do I've been sitting on for a long time, which I'm putting down here at the bottom. These are my personal to-dos. So the first thing I'm writing here is actually this is a better way to write it. The thing I'm thinking of is at some point here it'd be nice to be able to go like this whenever I'm printing, and then this would actually push into the base layer probably, because then at some point well, would it necessarily be the base layer? No. I don't think so, actually. Now that I think about it, because this is just giving, you would still keep all the stuff you've got here. Join, split, join, list, copy. These are just operators on the stringlet list. Yeah, so nothing here would ever change. It wouldn't have to replace the string 8 list in any part of the base layer. It would just be a new feature. So it could totally go into another layer or into this ASCII layer. But the point is you'd have things like this instead. And then this would be optimized. Like, first of all, it's easier to pass around this than an arena and the lists together all the time. And two, it would be optimized for things like small buffer increments and stuff. The string 8 list puts a separate node on each string you specify. So if you do something like 4 spaces and for an indent and then a parenthesis and then a string and then a closed parenthesis or whatever, each of those separate prints is a separate node and it chunks things up more than it needs to. It should really be a buffer, a high performance buffer. type situation. Now for the table, again, the only thing I'm going to change for now is to set up an output string. And then that's not really a thing anymore. The big functions thing. Okay. Now I have to go back to the old simulator for the code on things like histograms and tables. Let's have a quick audit of this now. That's no longer correct because the arena comes in here with a string, and so the scratch now needs to not conflict with that. Okay, I'm gonna look at the Mr. Fourth project real quick. It looks like we're doing build fly. That's fine, that's fine. So that means there you build the base layer. Here's the old bin dash build stuff. Lacey CS, yeah, let me pull that up for you. 1 second. MrFourth.com. Oh, you know what? I don't think there is an RSS feed yet. I have an RSS feed for the podcast. But I'm gonna take a note to figure out why I didn't finish that one. One more second. March 19th, 2025 to do blog RSS feeds. Okay. I have set the wheels in motion for that to get done. Yeah, so Lacey, if you would like to catch the new blog posts, the best way to do that for now is to sign up on the newsletter, which you can do on the homepage. If you get the newsletter, then you'll get a notification that way when I make a blog post. But I will see to it next time I do a website update, which will probably be in the next 3 months or so. So, don't expect it to come out the door tomorrow, but sooner or later I'll get around to it. Awesome. Thanks. And thanks for saying hi. I take it you're interested in something that I'm doing, so I'm curious to hear what that was, if you're up for talking about it. The PRNG ones are confusing. ASCII declarations, ASCII functions defined. All right, cool. Okay, I'm gonna engage some music now. Okay. All right, main.c. This is some old script that I put together. I'm gonna undo it. What will we do today? Well, we're not dealing with PE files. Let's pull up Mr. Forth ASCII.h, Mr. Forth ASCII.c. See ya. Okay. So today the goal is to test out these ASCII diagrams. So let's start with the histogram. I think in order to do this, it'll be best if I also grab PRNG. Don't need this. What I need is a quick PRNG to get set up here. Actually, you know what? I'm going to go a step further and make that one like that. Set that to be equal to that. Make our PRNG global. And then we'll grab a seed. Okay, prng.h. If I roll prng unital f32, so it'll max at 3. Let's give this a range of 10 to get this test started, or 30. 10 each level means if it gets 10 each time, it'll be 30. If it gets 0 each time, it'll be 0. And then we'll stick it in there. Do that 100 times. We got ourselves a histogram. Actually, let's do it 10,000 times just for fun. And then we'll look at the stats, and we'll look at, well, this is where it gets weird. How do I do it? Do I say that I can use a file print directly? In other words, is this the string version? and paired with it is printf or an fprint version. Like, is that how it goes? Because if I do that, then I can start doing things like fprint, vowels, size of vowels, count, and then I can give it a width and a height. Let's say it's 80 by 40. So we don't actually have to call this part ourselves. That's going to come anyway. Okay, let me look at something real quick. Okay, this code base is set up to manual profile with SPAL. Why is that busted? Fascinating. It's failing to link test exe. Let me check something here. shaders, graphical free type bin dash, desi dev. Right, you make the Mr. Fourth base DLL successfully. I never wrote down the instructions. So there's like, there's a way to use it when you want to use it like a, what does that one do? Okay, so that's about what happens with the shared functions. Those functions either get declared or defined, but not both, it looks like. That's just a link time symbol. Okay, so the only way this makes sense to me is if I'm actually supposed to do this. There we go. I need to write down those instructions at some point because I don't remember them. Gotta finish the base layer upgrades for sure. Anyway, let's see this thing. That's not what it should be. All right, we gotta go and update run fly here. It's trying to run bin dash and some, oh, it's an OBJ from raw instance. Ooh, glad I found that. That'll help to know that again. So I wanna see just the good old-fashioned test program run. Great. Mr. Fourth project, run fly. Run fly. Could we talk for a minute? Why are you using a footer panel? Don't do that. Load project. Load project. Run. Okay, so there's a histogram of 80 by 40. The first line is row 6. Yeah, it's 40. This doesn't use the full 40 because of the fact that wait, it's got 80 in this direction. It doesn't use the full 80 in this direction, even though it fills out the spaces for it. All right, that's kind of funny. That's because the histogram is Well, there's just something funny that happens with integers. So if you're generating data that's all made up of integers, then what you want to do with your histogram is quite a bit different than if you're expecting it to be more like a normal distribution or something. There's a kind of bucket aliasing problem, and I don't actually know what the analog solution is for that. Like the in integer outputs, it's easy. With floating point outputs, what is analogous to the anti-aliasing you do with the buckets? I actually don't know what that's gonna be. Um, might need to go and learn a little bit about data visualization via histograms to make that better. But the point is, since the maximum value here is 30, it doesn't really like stretching out the ASCII column to be wider than to contain multiple integers for no reason, right? So like it's not going to, or to spread across multiple columns for each bar for no reason. So if maximum is 30, it'll just use those 30. Now that might not be the way it should be, but that's the way it is. But we can test things out. So if we want to see it squeeze down, we'll give it a max of 20 and a height of 10. So that looks like that now. Now if I give it back all the space it needs vertically, run it a few times, we can see how much the histogram changes from one run to the next. I want to change a few things. So right off the bat, having that built in is kind of annoying. Maybe I want the ability to print the histogram stats. This will mean we can pull this in and this in. There we go. Now I just get a pure histogram. Let's look at... yeah, so, okay, Seven Artists is asking a question in chat, which I like. It says, uh, the way that I am handling strings, so me, Alan, the way I'm handling strings is alien compared to modifying them in place. And the question is there any strong argument for treating them as immutable? I mean, we could sit and talk about the pros and cons in lots of different ways, but I think that you get a lot less bugs when you aren't mutating strings in place. Mutating strings in place leads to funny things like uh, ideas like, oh, I'm parsing an input string and I'm pulling out identifiers, and what I could do is just modify the original buffer to create a null terminated string inside the buffer in order to, close that string, make it a null terminated identifier that I can reuse. And if you do that, then you go and later assume your buffer is still the contents of the original file. It's not, right? Weird stuff like that. Um, Also, code that does string modification in place often fudges things. So you get lots of code written by C programmers who are doing like buffer 100, you know, uh, and then all kinds of work that's like I plus plus. You can imagine like string fill buff, integer, s32 whatever, and you give it like you can do stuff like this, right? You start with an empty string and then you're filling it with x string fill buff. Or if you get sick of doing it this way, you eventually get to the point where you're like, okay, well, let me sn print f my integer something count new line, right, x. And so if you get to that point and then go like buff size of buff or whatever, you start to get a lot closer to at least not having overruns and being able to condense your string construction into a single line. So there are like ways to get there, but as soon as you switch to immutable strings, you can start saying, oh, well, I want my string to be, and then you take this part here, and notice instead of passing it a memory, we're passing it an arena, so it's allocating it. So if you start off with that, the point is not so much that they're totally immutable forever and all time. If, for instance, I put in my to-do list for the ASCII thing that I want to make a higher performance string streaming output data structure that builds things up in a single buffer. But the whole point is writing code this way, where it's correct and easy to get right. It doesn't have hidden buffer overruns or hidden capacity limitations that were based on some random number you typed into the C code. But it just builds, it creates at very little additional cost, because arenas are basically integers that you increment for the most part in terms of runtime cost. Most of the time, they might have under the hood allocations happening with the operating system sometimes. But when it's just that increment, which is what it is most of the time, it's almost as cheap as having it built in. In fact, it's certainly close to it, but it then handles any size string. There's no getting cut off and getting it wrong. So that's the argument for why I like to not use buffers in my string construction. Like, I don't want to have a buffer and fill it. I want to construct a string using something more like this. Now, I don't love format strings in C. I wish we had a better string constructing expression system than we do. Lua has a cool system where you can take two strings and sort of denote that you're concatenating them together with dot dot, and then you would imagine like the stuff like this could start looking like this, but then we would need a whole different language concept of the printing context where it's like, okay, what we're actually talking about here is this is a string concatenation rule. Maybe this has to be going through a little function that's like straight from int or whatever. But somewhere along the way, this has to get subsumed by a different kind of interpretation scheme that essentially makes the template for building out the string construction. So there's a bunch of stuff you could do there. Now, on the other side of it, the reason I just went all in on non-mutating strings was that I don't use any of this base layer string stuff for high performance ASCII data manipulation or processing. It's for the surface level APIs that I just want to know that I'm getting things right. So if looking at all that, you see the extra cruft of passing a size around all the time and not being able to just drop down to a pointer, and the necessity to like count how big a string is going to be before you allocate so that you have the right size, which it doesn't always punish you to like guess and then if you're wrong go again, kinds of methods still work. But if that really bothers you, then you might be looking at it from a perspective where you're doing a really high performance string processing problem through this API, which isn't meant for that. All right, another question I want to ask because it's something I spend a lot of time thinking about, and I actually have a YouTube video. It is Alien. It's just it. So to wrap up with 7 artists, I'm just gonna say it is kind of Alien. It does take practice to start thinking a different way. I would say embrace the format strings because it makes string construction so much easier no matter which other parts of the paradigm you do or don't want. Get comfortable with C format strings. It's the best we got. And or build your own, but that's a big project. That's huge. That's not minor. And the second thing you could look at is the the piece I didn't talk about there is I'm a little bit loose with what a string list means. Sometimes a string list is just a string that is constructed over time. You know what I mean? So that it can be allocated loosely, and that is a little bit of an artifact of the fact that I didn't build like I go for arenas and linked lists over buffers that that relocate themselves, and I use high performance data structures at the key points where I need to switch down to lower level, larger buffer operations. Um, okay, so I want to talk about this language question, so I'm going to read it out loud. But I just want to comment first that I actually have a video with me and Andrew Kelly of Zig and Ginger Bill of Odin, and me kind of trying to talk to them about the fact that I also sit on the fence and don't entirely understand the text thing. The conversation didn't go in all the ways that I was hoping it would. They also had questions for me, as it turned out. So some of it is me explaining my ideas to them. So if you go check out that video on my YouTube channel, it's in one of the conversation videos, or you'll find it in my podcast feed. You can hear a little bit more of what I have to say about that there, and what they have to say about it. But I think I wouldn't say that the reason. So I think usually, okay, let me read the question first. The question is, what's your take on Rust/Zig/Odin? Question mark. Do you think they address a real problem? That's a good question. I'm curious because I see that most C programmers think that all those don't make sense having C. But I get the feeling that a lot of those opinions come from the fact of having a lot of C experience, which is not the case for all. By the way, I don't stand firmly in either side. I'm just curious. Uh, so let's take this in a couple steps here. The first thing is I've never actually built any languages like these, and I don't see all the stuff that the compiler developers see. And I want to give some credit to the fact that I don't think people waste their time for no good reason on gigantic projects. I'm sure that everyone who's worked on these things has seen and appreciated problems that I have not. And so, like, let's just name up front that until you build your own, calling them all horseshit is a little bit presumptuous. Secondly, I'm not actually in the camp that says we don't need these because we already have C. C is a dumpster fire, and so it makes sense to think, why don't we replace it? The reason I don't care is because I don't think that the next that I think that there are much bigger breakthroughs to make in computing than what that vision of rewriting C with better design decisions seems to cast. That casts a future where I still sit in front of a ASCII, a typewriter style keyboard and type into plain text files and communicate with compilers that talk to me in plain text. And if that is still the future of computing that you're building towards, then I think it makes perfect sense to replace C. Now, I'm not getting into the minutiae here of if I like Rust, Zig, or Odin more, because I haven't looked at any of them sufficiently to even say. I'd probably, if I had to take a random guess, say that I like Rust a lot less than Zig or Odin, on the basis of the fact that I've heard that there's a lot more complexity in Rust. Further, based on just glancing at the complexity of Zig versus Odin, I suspect I would like Odin more on that side. Although I'm also curious about things like Zig's comp time, and a lot of the tooling around Zig is always looking really impressive. So I couldn't say that I have an opinion one way or the other there. Although honestly, they all seem more complicated than I want. All I would really, really want is like C with module systems, sane integer, a sane integer type system, and out of order declaration, and that's about it. Like, I don't really want much else besides what's in the language, but just in like freed from the shackles of the 30, 40 years of other stuff that C was entangled with that isn't relevant anymore. And all of them seem to go farther than that with slices and complex type system things and stuff that I'm like, I don't know. Um, Now, with all that said, like I said, I don't think that's the right direction of progress. I think that is incremental. There's an asymptote of how good. Let's talk about what we're really doing. Like, I feel like this is a conversation that I come at from a perspective with a wider angle than most people tend to have in mind when you start talking programming languages. Programming languages are one cog in a machine. The whole machine is all of this, like my chair, desk, keyboard, monitor, mouse, the whole internet that lets me get to you and whatever setup you have to hear all of it. That whole machine also includes 4Coder, my text editor, the C++ and C compilers that I use, the linkers that I use, the operating system that lets me run all these programs with one single unified workflow, and also lets me define and run the target program. All of that is a gigantic interface for constructing software. That's what we built. That's what we needed out of computers, and we built an interface for constructing software. And the language is a piece of it. And the idea of incrementally improving the whole thing by finding new ways to express yourself into text files feels to me like a very narrow way to think about what's next for computing. I at least for me and what I'm interested in, I'm looking for something a little that cuts a little deeper into how we build the whole interface for constructing software. Now, there's a couple different directions for iterating on that. One is, how do you get away from the typewriter interface? That one's really tricky, and I'm not sure I'm the right person to solve that, but I do wish that I didn't have to. Like, this ergonomic situation for constructing software is not great. Um, but what's a little closer to home to me is the data structure that is used to define the graphical interface. It doesn't have to be text files. It just is what we're doing because we got that one up and running, and the world runs on software now, so we can't exactly just stop unless we are all good with losing everything we built with computers, right? However, I think we have to cut back down to the bone a little deeper than what we can do by iterating on the language if we're ever going to get large wins again. There's other options for how the tiny microscopic building blocks, right? Yeah, if you really dig into how the whole thing works, there are so many little built-in assumptions. So the way a compiled language works is you write code and then you submit that code to a program that translates it all at once, and it either translates all of it or it fails. And if it succeeds to translate all of it, then it gives you a program, and then you run that program, right? That's a set of assumptions about how constructing software should be done. What if I wanted to live in a world where my software is always going to be running, right? If you become a web developer, this becomes a little more true. You have a server that's up and running, and you've got other ones that you're modifying, and the system starts becoming alive. But you're still controlling all of that dynamic through an interface that was originally developed with this batch processing of construct some software, hand it off to a compiler, get back a program, run it. That whole process of conversions that is sort of got discrete time steps makes a lot of weird artifacts where you can't actually control the living system as easily as you'd want. So point of all that is to say, I just think that I'm not that interested in talking about languages because they are like a small, narrow portion of the entire interface. And so half of what I'm doing is just talking about different ways that I can expand my interface from day to day for myself, just to help other people start thinking this way, because I've found that that I don't even know how to explain these ideas to most people in a way that they can even resonate with them. So I'll comment on the follow up. I appreciate the feedback, and I do think there is some sense in having a little humility when a lot of people are drawn to something and you don't get it. That doesn't um, necessarily mean that they're right, that there are so many people, but I think having a little humility in your approach to it is a good starting point. The trick, though, the catch, is culture moves like a mob, and it doesn't necessarily move towards the best interest of what you're actually looking for. It If you become a part of that culture, it probably makes perfect sense to go with the way that culture is thinking, right? But we have to watch out, because a lot of times what would be best for you might be quite a bit different than what's best for a community of language developers, right? The thing that you might actually need is a thought process that might be alien to the culture you're choosing to be a part of. And something that I like about C that you don't get in Rust and at all, and you get a little bit more mental freedom in Zig and a little bit more mental freedom in Odin, but the C has like no culture, so you're good to go. Like you can do whatever you want if you're a C programmer. You can be your own person, and you don't have to have other friends who write C code anymore. Once you've learned how to do it. Um, okay, so let's get back to my project for a bit, shall we? Hope that didn't sound rude, but I'm just like, let's do the thing. So the histogram's looking okay there. It's not very stable. What happens if I go for like 1,000,000? That's too much memory for the stack, so let's put it on the arena. Okay. Now that I'm taking 1,000,000 samples, the histogram is very regular. Okay, so check this out. Here's a uniform distribution. Oh wait, look at that. Yeah, so this here is a good example of funny little aliasing artifacts in the histogram process. Paging Turner says something that I'd love to expand on the topic of the programming language interface problem we were talking about. So it's such a fun topic. I can just go all day, but I also am looking for these artifacts to fix. The thought is that they're saying that the dream world would be composable compiler pieces. So you have a bunch of little micro compiler logic paths that you can, and data nodes, I assume, that you can kind of have run through these compiler pieces and get the different kinds of behaviors you want. And it's a good dream. Like, I like that dream. The way we think about language construction almost precludes this dream from being possible, because we think of language definition as a thing where you define a language first, and it has some possibilities of what it can and can't guarantee, and what expressions are easy and hard. You fix one landscape, and the nice and you do this so that you know what's correct code, what's valid code, what does the code mean. You define it all. You define it all, like, absolutely, right? The only exception is that if you're C, you're allowed to, or C++, you add tons and tons and tons of extensions. I guess this happens in other languages probably too, but at least in the languages I've used, it's C and C++, have an overwhelming number of compiler extensions because they get used for so many real world scenarios that the tiny little vision that the language had just doesn't cover it. And it feels to me like that's, you have to, if you want to see how composable compiler pieces could even work, the first thing you'd have to do is drop the notion of a language, right? You would instead have to figure out how you're going to encode information that means something given a set of pieces, but doesn't necessarily mean something if you don't have the right set of pieces, or something like that. Like it somehow, and this is why I like to talk about changing the data structure instead of changing the interface sometimes, because it's almost like raw text files are too unstructured by themselves. There's no topology to them in the data in any way. unless you know how to resolve identifiers, and then you need to come up with a plan for how that's going to work, i.e. the language, right? Yeah, C++ is pretty horrendous, and yes, operator overloads are probably the best thing from C++ that I miss, both and for sure. Okay, so you can see as you increase this number here, what happens, you're basically rolling more and more uniform variables and adding them together. You get something like a normal distribution as this process continues, which is cool. But I want to track down that artifact and start thinking about how the histogram printing works. Okay. Okay. Doesn't happen every time either. It's only a possibility. Let me just look through the code and start seeing if I can get a handle on it. It's been fun chatting, but I think I need to take a break from reading the chat so that we can get into the code here. But y'all keep chatting. Don't let me stop you. Okay, so the way the histogram is getting printed, let me just read the code out loud to myself for a second here. We are getting the minimum and maximum values from the whole input, data set, and rounding them to integers to get started. Then we're finding out our bucket width. So our bucket width is at least 1. So this is where if the bucket widths could get smaller, the problem would be, okay, this is creating the integerization effect that I'm getting, which is sometimes appropriate and sometimes not. So what I need to think about is sort of like I want to specify a precision parameter or something. So if I'm dealing with integers, then my precision might be 1.0, and if I'm dealing with floats, my precision might be something more like, 1 in a million or whatever. What is this? 10, 100, 1,000, 10,000, 100,000 million, right? Like that might be my precision for non-integer cases, or maybe that could be my precision for non-integer cases. And then for integer cases, you're just saying there's your precision. And the point is, the precision is a granularity level at which you want to say two things this far apart should never be in the same bucket. Okay, just to clarify this, when we're grabbing a histogram, there are two different possible scenarios. Sometimes the numbers that create the histogram is just a set of values, and each value, like I don't want to put this, in a way what we're trying to do is look at the density of various values through the distribution, right? If I you could think of it as saying there's these buckets, and the reason we do buckets is so that we can discretize it. There's like a continuous version of it, but I don't know if I want to get into, like, that has nothing to do with this case. I have to render this a discrete output anyways. The buckets gather up numbers in a certain range, and then we report how big that bucket is. But there's a problem with that, which is if my bucket is wide enough, if my granularity is integers, for instance, so I can get 1, 2, 3, 4, 5, 6, 7, blah, 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 but my width is just a little bit larger than 1, it's like 1.2, then once in a while I'll have a bucket which contains something like 5 and 6 together. And so it'll look twice as tall because it'll look like, say 4, 5, 6, and 7 are all equally likely, but 5 and 6 go in the same bucket, so that bucket is twice as likely as the buckets 4 and 7, right? So the precision idea is the idea that there is some size of bucket that you cannot have a bucket wider than that. Now, this is something different. This is something you cannot have a bucket more narrow than 1. And the reason for that is, similarly, if I have integers, 1, 2, 3, 4, 5, 6 as my values, and then I have buckets that are more narrow than 1, say, say that width is very large. So if I have 100 ASCII characters in my grid to work with, and the range is only 50, then this comes out as 1/2, right? I have a range of 50, but a display width of 100, so I come up with a bucket width of 0.5, of 1/2. What's going to happen is half of the buckets are always going to be empty. The bucket that contains everything from 1 up to but not including 1.5 will include all of the 1s. The bucket containing everything from 1.5 up to but not including 2 will be empty. And that'll be true for every other bucket. The whole way through we'll have buckets that are full and empty, full and empty, full and empty. That's not a useful histogram. So the precision parameter says one thing, which is buckets can't be too wide because then they'll alias. But then there's the other thing, which says buckets can't be too narrow because then we'll have gaps. And I need to figure out what that means. There's like a minimum and maximum precision parameter or something. And if you're in integer land, okay, yeah. So then the next step here is I need to figure out how the buckets map to what you visualize, because that's not one-to-one either. I used to have it that way. So this code is working in the following way. I look at my bucket width here, and then I allocate an array of counters. Each array counter is counting how many elements are in each bucket. So these are my buckets. Buckets are actually just an array. A system of buckets is just an array of counters, and I have to increment each bucket counter once for each number that lands in that bucket. So the number of buckets I have is whatever I put here, and I'm saying it's width. That means I'm thinking that each ASCII column is a bucket. And then I'm taking each value, and I am interpolating that or linearly casting that from a value here, right? So S is the value. Histogram min is the smallest value, so this is 0 or bigger now. And then I divide by the bucket width to find out how many, which bucket I'm in, right? So this could be the number 100, right? This could be, S could be 100 larger than the min. But if my bucket width is 5, then what this would mean is that, you know, I'm in bucket 20, right? There are 5, you know, each bucket, the first bucket goes from 0 to 5, the second bucket goes from 5 to 10, et cetera, et cetera. So dividing by the bucket width tells me from the number I'm at to which bucket I'm in. And then I'm turning that into an integer, indexing the buckets, and incrementing the appropriate bucket. And I'm also, at each step here, calculating a bucket max. This is the largest value in any of the buckets. That feels silly to me. The first thing I'm going to do is do that different. I think we just scan the buckets after. Okay. Okay. Now, this logic is correct, but these buckets can't be one-to-one with what goes to the screen. What now needs to happen is that I have to, if I'm going to have, so what I need to start thinking of is instead of having buckets be one-to-one with the visual columns in the ASCII, I need to assign buckets to columns in sort of a parallel way. And they won't necessarily all have, it's not like each column will necessarily have the same number of buckets. There'll be an unevenness to it. But I'm not going to take the sum of the buckets anymore, right? So what I'm doing right now is if I have a column that, you know, or i.e. a bucket that is, you know, it has a width of 2, or let's say it has a width of 1.5, right? So not as big as 2, but it's got a width of 1.5. So it can, but doesn't always have to. It's even better if it's like really small, like 1.1. It can, but it doesn't always have to include 2 integers, right? That would be a problem if my data is spaced out like integers, because I don't want to treat that as, I don't want to have one of those buckets that's double the height it should be. So instead what I would have to do is say, okay, the precision requires that buckets be a width of 1 when it's an integer scenario. And so instead of having the buckets be these ranges that are based on how wide the screen is, what happens is after the fact, when the buckets are just based on the precision problem, the precision concept, and then I assign a couple of buckets to the first column, a couple of buckets to the second column, maybe 3 buckets to the next column, and then a couple buckets to the next one, and a couple buckets to the next one, and so on and so on and so on. I distribute the buckets amongst the columns, and I take the max, right? That's what I could do. Or I could even look at like the max and the min and color everything below the min solid, everything between the min and the max in like wobbly, something medium, and then blank above, right? I could somehow craft a description of the min and max with the visualization. I think that might be a way to do it. So let's try and look at a couple of versions, just max, min and max being visualized at the same time in each column. But to get there, I'm gonna kind of need to chew this up and spit it out a different way. So So I think I'll just throw it all into an if zero and then start consuming it little bits at a time like this. So that comes up for sure. That comes up for sure. Now the bucket width for now. Yeah, so we don't have a good system of parameters here. Alright, let's try to just bundle some stuff and see if that gets us there. So the data struct will just be a way to carry around this sort of slice thing that I have here. His data will come from that. The pH test asks if I consider using Unicode characters instead of ASCII. It's an interesting question. Maybe that would be worth exploring. Yeah, maybe I'll play with that on another occasion. I've got my slate filled with just, these discrete grid-based problems already, but Unicode could be an interesting upgrade to this to explore as well. Okay, so that bundling just means I don't have to pass that triplet around manually everywhere anymore. And then that gives me a little more thinking room for complicating this. So when I go to print the histogram right now, I'm passing it a width and a height as parameters to how much space I want to give to the process of printing this histogram. So Um, Having to think here. What would I call this? These are the control parameters for the conversion of the histogram data into an ASCII histogram. So maybe it's more like, instead of display, it's more like histogram. Instead of display, it's more like histogram print or ASCII params, or just params, the control parameters for converting the histogram data. I think it's just got to be params or like control params. Maybe it's a long one because it's just a parameter bundle for a function at this point. It's not anything more high and mighty than that. And then if I want to, I will throw in how can I determine what the precision should be? It's like either the precision should be 1 or it should be something fairly small. I don't know. In this case, we would want a precision. I mean, we could leave precision 0 and say that there's a default as well. Okay. So there's a little step forward. Now we're just doing everything wrong. So I switch over to trying to make it right. The params will provide a precision, and we'll say that the bucket width gets a clamp bottom of not 1, but something more like 10, 100, 1,000. I mean, that's still assuming you know anything. Million, billion even. The problem is if the bucket width is super, super small, then that means there will be billions of buckets. Unless I get smart, right? Unless I stop. Okay, so what if I think of each bar in the output, each ASCII level bar in the histogram. What if each of those is a bucket? And the reason I say that is one way or the other, like if I go really, really, really precise here, what I'll end up doing is having a bunch of buckets that are all empty and then putting one element into a few of them, and then collapsing that down into a column is basically the process of doing the bucket work again. So my idea here was off. But instead I could say each bucket is a collection of values with a min and a max and a total and therefore an average. And a count. Min, max, total, count, right? Min, max, total, count. Then the question is, I mean, it's not like you want to take the count and divide the, yeah, the count is supposed to tell you the height of the bar. But we can use the precision to weight the bars. So the way the precision works is if I have a bar that stands for one bucket and I have another bar that stands for 2 buckets, we would take the total number of hits and divide by 2 on the second bar. Does that make sense? Let's just say if you don't set the bucket width, the default is 1, or the precision, just call it the precision, then the default is 1. Now, the first bucket starts at histogram min. And we make one bucket. So we will do let's just compute hist range So the range of the histogram data divided by the precision. Let's do it that way. So you have to tune the precision manually, I guess. You tune up your precision, and that tells me how many buckets to create. Then there are going to be these bars. And that is given by the params width, because those are the bars in the ASCII grid. And what I need for a bar is a little more complicated than what I used to give it. Okay, it's going to have a count. It's going to have a bucket count. It's going to have a point count. Data point count. Bucket count. Min, max, total. Initially all 0. Except let's just have a quick scan over them to set all of the mins to min F32 or max F32. Inf F30. Man, I have this. I just don't remember what it's called. F32. Inf F32. Yeah, okay, so that is a thing. There we go. We'll set the maxes while we're at it. Totals will all be 0 initially. That'll go up every time we get a data point. That'll be calculated once. Okay, so this part is tricky. Let's say I have 50 buckets and 30 bars. Then somehow I need to assign the 50 buckets into 30 bars in a way that has the following properties. One, it shouldn't distort the layout of the bars. They should stay in the same order they would have been if I could have seen each bar separately. And they should have been how do I want to describe it? They should have been, I don't know what it is, like dithered. The distribution of bars should not be more dense in some areas than others. There should be uniform density. Now, it's okay if there's a regular sort of remainder build up. You know, we could just say that the rule is going to be, well, let's think about a couple ways we do this. How do we want to map from a bar to a bucket, right? Or from a bucket to a bar. So we're trying to figure out how many buckets map to this bar. How do we map bars to buckets? How do we map buckets to bars, I mean? We're trying to ask how many buckets are mapped to this bar. How do we map one bucket to a bar? So the very easy way to do this is, so here we'll init and max states. Here we'll calculate assign buckets to bars. So for this, I'd have to scan each of the buckets, map a bucket to a bar by doing, it's a bucket count to bar count conversion with it feels like it's something like this. I times bar count divided by bucket count, right? This would be the kind of thing that's like, this is the conversion ratio. Now as integers, that, if I just took that division, it'd be garbage. Because then I'd get like 1 or 2 or something without the ratio, right? But with both of them together and the times happening first, I think we get the right thing with integers. So I is 0. Say there are 50 bars, 30 buckets. This becomes 0. That is correct. I is 1. There are 50 bars, 30 buckets. This becomes 30, and then 0. That is correct again. This becomes 2. This becomes 60, 50. This becomes a 1. This becomes a 3. This becomes 90, 50. This is also a 1. This becomes 4. That's 120, 50. That's a 2. This becomes a 5. 150 divided by 50. This becomes a 3. I think that does the right thing. So then what would happen is bars bar index dot bucket count plus equals 1. So that's how it works if we do it that way. But we could also try to do this more like this, which is calculate the number of buckets assigned to each bar. And so now we're going over the bars instead of over the buckets, and we're going to try to calculate it in place. Let's see if there's a way I can find to do that. So this, we would need to find out a range, because we can't map a bar to one bucket. We can map a bar to its smallest bucket. First bucket index equals I times bucket count divided by bar count. And then 1 past last bucket index is going to be all of that again, but for the next bar over. Right? So here I've flipped the ratio. Let me see if this makes sense. If I put in a 0, this calculates 0 times 50 divided by 30, which is 0. This calculates 1 times 50 divided by 30, which is 1. That's not right. I thought if I just multiplied by the bucket count and divided by the bar count, I would get the right thing. But that can't be right, because if I put in bar number 1, its first bucket index should be 2, right? 0 and 1 here. Let's just write this down. Let's see here. Here's our example: bucket count, bar count. Assign buckets to bars. So bar, bucket, bucket, bar. So 0 maps to bar 0. Bucket 1 maps to bar 0, right? 1 is 30 divided by 50, which is 0. 2 maps to bar number 1. 3. 3 times 30 is 90 divided by 50 is 1. So yes, bucket 3 goes to bar 1. Bucket 4 goes to bar 2, because we get 120 divided by 50, that's 2. And then we get bucket 5 goes to 3, because bar 5 times 30 is 150 divided by 50. That gives us 3, right? Then we would expect, okay, so we are now, that is a sort of a single cycle, and I would expect the cycles to just continue like that. So 1, 2, 1, 2, 1, 1, 2, 1, 2, 1. Because here we're seeing 150, here we're seeing 0. The 150 represents the spot where this divides cleanly into an integer, and then the next one adds 30, and so it doesn't cross the 50 boundary yet, and then it crosses with the next one, adds 30, right? And it's just this is basically the modulus of, or this is the this is the quotient you get when you're adding by 3 each time, right? You're adding by 3, dividing by 5, or you're incrementing by 3, but then doing divisions by 5. This is the rate at which you progress through the 3 states, right? Modulus 0, modulus 1, modulus 2, modulus 0, modulus 1, modulus 2. Yep, that makes sense. So now the question is, why does my reversal code not work? If I put in a 0 for the bar, I get a 0 out. If I put in a 1 for the bar, I get 1 times 50. Oh. I probably just need to get this to round up. So let's write out the code a little bit differently. So I'm saying here, when I'm assigning, what I'm actually saying is that bar equals the floor of I times bar count over bucket count, right? How do you solve for bucket in an equation like that? That's the question. How do we do this? How do we do that? Jay Calabro, hey, nice to see ya. Things are going well. How are you? So let's see, what would 3 map to? 3 would be 3 times 50 divided by 30. So that's 150. Yeah, that would come out as 5. So this point will work. This point will work. It's these intermediate ones that don't work. At a modulus of 1, it's finding the smallest bucket that could overlap, right? So if we drew these like this might make more sense. I'll use a pixel that goes 5 at a time like this, right? And we'll do, so each of those is 1 pixel, 2, 3, 4, 5. 2, 3, 4, 5, 2, 3, 4, 5. I'm gonna put in bars to divide every 5th one. 1, 2, 3, 4, 5. You know what, we can do this without using pairs. 1, 2, 3, 4, 5, just as long as there are gaps. 3, 4, 5, 1, 2, 3, 4, 5. And then this one is, so these are buckets. And then these are bars. Sorry, these are the bars. They're like this. And these are the buckets. Right. So what's happening is 0 here goes to 0, 1 here goes to 0, 2 here goes to 1, 3 here goes to 1, 4 here goes to 3. But if we run the same exact logic the other way around, what we get is 0 in the bucket goes to 0 in the bar, or 0 in the bar goes to 0 in the bucket, 1 in the bar goes to 1 in the bucket, because you go here and you look across. But that's not how this mapping works. This should be looking not for the thing that lines up with where this starts. So it's not so easy to calculate the first element, but it is pretty easy to calculate the last. Is that what's going on? Yeah, I think so. So this one maps via these characters up. But then this one maps from these characters here down. So you'd get 1, 3, 4. So we just have to know that at the beginning you start off at 0, and then when you look down, whichever one you hit doesn't go to the next bar. But of course, another weird thing here is there is a little bit of extra distortion because I'm just using integer rounding, what's happening is this goes to this goes to this, but really, I feel like maybe we want to associate these with correlations of maximum overlap, right? So this bar should maybe be the one claiming bucket 3 in order to minimize the distortion. But that is not basic rounding. That is a little more tricky. How would I do that? I'm not sure. I have a cursor that starts here. You can say your first value, your first bucket here is 0. Yeah, this is also going to raise the question, how do you make this mapping go faster? I don't know if I want it to be too complicated, but all right. Cool. When you talk about your open source project, do you mean your debugger? The like, I think you were working on an experimental debugger, if I remember correctly. So this feels like it's sort of like nearest rounding. This and this are equal. This is, well, it's not nearer to this. It's nearer to this, but it overlaps more with this. Well, how do you do? Yeah, nearest would mean you look at 0, 1, 2, 3, 4, 5, 3. Yeah, it's 2 in that direction. That's nearest. That's nearest, but that's not. I just don't know. I don't know a good way to do it that is. So, I mean, there is one good way to do it. If I engage with floating point arithmetic to make the calculation and then round. So the first bucket index I mean, even if I really want to recreate this, I'm not even sure that I know how to do that with floating point, because I don't know how you know when you round up versus when you round down. Hey, Terry's Python, I'll update you. I am trying to figure out right now, I am zoomed in on the problem. I've got two different discrete I don't know. I have a ratio integer programming thing. There's a certain number of buckets in the histogram invisibly, and then a certain number of bars. And I'm trying to make an assignment. Like they both range over this data. So that this is the minimum of the data. This is the maximum of the data. And I want to make a mapping between them so that I can assign buckets into the bars in a way that minimizes distortion. Hey, you got it. It's the bar that contains. Yeah, Horowin, you got it. So the way I. So to go from a bar to a bucket with this mapping would be to look at the center and then look at the matching bar. Now to reverse it, I still don't know what I would do. But that would turn this mapping here into, let's see, bucket times, okay, so this tells me which bucket I'm on, like this, and I multiply it by 3 because that's my bar count, right? There are 3 bars, and that's why each bucket has 3 subdivisions in it in the picture. So I'm multiplying by 3, 0, 3, 6, 9, 12 for each bucket, but I'm gonna need to add something in right here. And that is 1 in this case, but in general, it would be something like bar count over 2. So this would be 1, 4, 7, 10, 13. And then you divide by the bucket count because well, the bucket count is the one that's like 5. So you're counting how many 5s you've done, which is gonna land you here. With the number, not with the 10, but with 2, right? That's gonna map you from there to there by saying 13 becomes 2. So that maps bucket to bar. And then the question is, can I figure out how to map bar to bucket in such a way that it gives me the first buckets of the bar? So It's not good enough to look at the middle this time. That doesn't quite get me there, because this middle doesn't do the right thing. It's not good enough to look at the first element. Now the second element happens to work. Why is that? Okay, so ignoring this one for a minute, the idea is each of these is one of the sort of, right, I have 3 bars and 5 buckets. So there are 15, the ratio there, the ratio of 5 to 3 induces this 15 because I'm working over a grid of like discrete cells in my head here of where these things discretely line up, and they do so on a grid of 15. The splitters here indicate the separation between each bar in that grid in that conceptual grid, and these splitters indicate the division between each bucket in the conceptual grid. Now these ones in the middle actually meant something different, and I wasn't sure the best way to label them, but these are like connectors showing me how this one maps to this. So if I were to use the picture suggested by Horowitz, we're using the center of each bucket to figure out which bar it's in. I was originally saying that the mapping should be the maximum overlap, and then the rule, it can now be simplified to where the center of the bucket lands. So I can't move the floor over, but if I were to do the rest of the rewrite, what would happen is that bucket would need to equal something, I don't know what, of bar times bucket count minus half bucket right. I multiply both sides by bucket count, I subtract the half bucket, and then I divide the bar count. Yeah, the grid here is really just an integer ratio mental processing figment. It's not, there is no 15 actually in the data anywhere. There's a 3 and a 5. I just picked 15 so that it was divisible by 5 and 3 so that I could look at the fractions. You know, that's what I'm trying to say. I'm looking at the polyrhythm across space. So, does this work? It looks like it kind of would, but this is a little bit concerning. So let me run through this. Bar 0 times bucket count is 0. Minus half bucket is a problem. In theory, if this was like sealing right here, if this was seal, then these wouldn't need to be integer operations, right? I could think of this as a fraction for a minute. Well, Terry's Python, it's definitely not um, a one-to-one mapping, so I can't go from a bar to all of the buckets, but I should be able to go from a bar to the first bucket. Now, can that be done without just storing it as a data structure? I don't know, but I get the impression that it probably can. Um, the only problem is trying to solve this equation with the floor in it is probably impossible. And so this is only an estimate, like a guess in the right direction, but like, yeah, somehow. I mean, there's one way I could do it by hand for this case, which is um, basically we can see 0. Bucket equals bar divided by 3 times 5. Else if bar modulo 3 equals 1, that plus 2, and finally that plus 3. The question is, how would I make it work without hard coding in the assumption of this particular ratio? I mean, it definitely looks like it should be bar divided by 3 times 5, which, I mean, could also just be bar times 5 divided by 3. That does the same thing, right? Well, no. If this is modulo 1, then it's like bar minus 1. And if this is modulo 2, this is like bar minus 2. Gotta be careful there because that division isn't wiping away those differences anymore, so it's going to get bigger. But then how much does it get bigger by? Well, this is bar times 5 minus 5 divided by 3, which is bar times 5 minus... Oh, these get a little confusing. I was hoping somehow the 2 and 3 would become more clear. The part of it that looks close is this. We can do bar times bucket count divided by bar count. If we come in here and switch it, we get this wipes that out, and this just gives you the correct spot here. Then the question is just how to use the moduluses to get the 0 to 3 in a way that works for any ratio. Right? If I could somehow use bar modulus the bar count, without having to hand code it. 1. It's tough. I don't know. This feels like the kind of thing where there is probably a way to do it, but it's I don't know how to find it. It's characterized by the fact that if you map it the other way, you get this. But what else? I mean, why is this inversion wrong too? We're getting the seal part. Why? Just to make sure, I want to get the bucket. So I take bar times bucket count. Yeah, it's not that simple. Yeah, if there was going to be a modulo at the end, it would have to be modulo 5, right? Because it's going to be, in theory, possible for these numbers to be any of the zero values between 0 and 4, since that's the size of one cycle in terms of the number of buckets. So if it's going to be modulo 5, 0 times 3 modulo 5, 1 times 3 modulo 5, 2 times 3 modulo 5. No, that doesn't work. Two goes to 3 this way because let's see, 5 divided by 3 gives you 1. Yeah, the exact way it adds up is a little hard to see because I'm assuming 5 and 3 here, so certain things are look like patterns but aren't. The temptation I have is to say, like, okay, look, this lines up at 0, this lines up at 1, this lines up at 2. Maybe that is part of the pattern. Not that this is where the one you want to match, but this is also lining up at 2, like the modulus, the alignment here. But that's only because of this particular ratio. You know, if I put 7s and 3s together instead of 5s and 3s, then it would take it would increment by 2 every time you get to the next bar. The shift of the pattern would be different. In particular, I guess the shift of the pattern is, let's see, when it's 3 versus 5, you get 2. Kind of like 5 modulo 3. When it's 7 versus 3, you get 1. No, it's not always a 3 to 5 ratio. I'm just using that as an example to explore. It could be anything. 1 to 1, etc., etc. This might be not worth trying to solve it exactly. I think I'll move on for now. This isn't even my strong suit, so we're going to go with assign buckets to bars. I'm going to actually rename this to first bucket index, though, and say the goal here is if we've never touched the bar index before, then we set the first bucket index to bar index. Hold on, let me just look at it one more time. It feels to me like there should be some way to increment through the counters here that I'm missing. What if we did it like this? Instead of this, we'll just start an infinite loop that starts with U32 bucket index equals 0, U32 bar index equals 0. Maybe we can still say we're doing this as long as bucket index. Well, no, I'm going to well, okay, it's still going to be while bucket index is less than bucket count. And we're going to say bar count cannot be more than the bucket count for now. Maybe we... No, yeah, that's what we'll say. If we get to a point where we have so much space to draw into the space we're given that we could make our bars wider, we'll do that, but only if we can make that uniformly wider, right? Now the goal is to increment both of them the right amount. We're going to do a pass here, so why not, instead of having an in-place calculation of bar to bucket, what if I just calculate it correctly, right? And I want to calculate it correctly There'll be an in-place mapping of buckets to bars still because of the fact that we need to grab data points, figure out what bucket they're in, and then assign them to a bar. But let's see, that's bucket times bar count plus half bucket divided by bucket count 0 times 50 plus 0 times 30 plus 15. It's 15 divided by 50. 0. 1 times 30 plus 15 is 45 divided by 50. 0. 2 times 30 is 60. 75 divided by 50 is 1. 3 times 30 is 90 plus 15 is 105 divided by 50 is 2, right? Okay, so that works. Then here the goal is to increment by the right amount on each side to so the easy way to do that is for as long as we can we calculate ugh, I hate it. Okay. Calculate no. Yeah, Twitch is not a great place to try to share this thing, but let me check out what you got here. Bar bucket count equals floor bucket count plus half bucket count times bucket count. Bar bucket count. Oh, you're going hardcore. This is cool. You figure out that the floor is just the thing minus the modulus. And let's see, let me just skip to the end and see what you got here. That's a great trick. I hadn't thought of approaching it that way, but I like that. Bar times bucket count plus 0 minus half bucket divided by bar count is less than or equal to bucket is less than or equal to bar times bucket count plus bucket count minus 1 minus half bucket divided by bar count. So it's pretty hard to follow the last couple equations here. Let me grab this one you've got, the inequality at the end, and paste it into 4Coder. See if that'll make more sense. What do we got here? Presumably these go together like this. This 0 goes with this piece. This goes here. Yeah, I don't know. Yeah. I think that it might not be doable, or it might be a trick that I don't know. It seems like it should be so doable. It's just the mapping of discrete spaces. It's how, I don't know, it's a thing that has to happen all the time in 2D rendering and stuff like that. Like the casting of texture onto pixels solves basically this problem all the time in a more complex way. But maybe the fact that I'm trying to do it the sort of like old school style right on the integer grid is what's making it so much harder, because I can't avail myself of any anti-aliasing technique after the fact to make it just work. It's like trying to draw a line by hitting all the right pixels. You know, it's one of those kinds of things, which I've never really been good at. I wish I could sit down and just master integer programming and grid programming and stuff like that one time, but it's kind of a lot. Anyway, what I'm looking at here is I increment the bucket index, calculate the so this kind of works, but I think it can get a little better. I'm going to spin up my picture again here. If I have a cursor here and here, I should be able to figure out that I need to advance by 2 from what I've got. Is what my contention. I should be able to figure out something that's like bar index plus equals 1, bucket index plus equals blah. I think that should be doable. And okay, so first idea here, to advance to this is 2. It's plus 2. Paging turner, yeah, that could be the way to do it. So that would mean I increment the bar every time, because that's the dense. No, I increment the bucket index every time, which is not what I'm doing, but that seems reasonable. I'm bouncing all over the place trying to track down different ideas. But yeah, I don't really know the line algorithm very well. I should really go and master it sometime. The Bresenham line algorithm, yes, exactly. Now bar count can't be greater than bucket count. Okay, so if bucket count, if accumulator becomes greater than or equal to the bucket count, then we will increment the bar index, set the first so the 0 is going to get 0. We increment the bucket index and the accumulator. Except that that's not quite enough here because that's going to give us the wrong rounding, I think. This one is 0, 0, then plus 3. Plus 3, I'm at 6. Then it will... Then I'm at 6. Then when I plus 3, it doesn't know that it's actually incremented again because the accumulator started with the wrong value. The accumulator should have started with bar count over 2. So now we're looking at this, and then we go, okay, here's 0. The 0 case is automatically right. Increment it to 1. We are at the value 0, 1, 2, 3, 4. Not greater than or equal to the bucket count yet, which is 5. So increment it again by 3. Now we're not at 6, we're at 7. So we roll it down to 2. 0, 1, 2. And we increment by 3. And there we go. Yeah, so that looks right. That looks right. What happens here when I do 0, 1, 2, 3, 4? It checks bucket indexes, bucket count, so then it becomes 5. The accumulator will go here. The bar index will reach the end, so it will go past the end by 1 here. So we increment the index, check that we're not at the end already. Then we increment our accumulator, and our accumulator is already set to be a little bit offset, so we will get the right alignments. And whenever we do that, we increment the bar index by 1 and we store the new bucket index. Now, if bar count and bucket count are the same, what will happen is every time you come in here, you increment. You see that this is equal to this, you increment, you store, you return it back to 0, right? Because they're the same. But if bucket count is even slightly bigger, then this will figure out how to distribute them fairly. And it'll assign that right into the bars so that now I can get counts by looking at the differences, and I can map a bar to its bucket through this member that I store. To go the other way around, I'm going to go from bucket to bar with just a little integer programming there. Okay. So that's the new bars. Now what I have to do is I have to scan the existing data. So this is scan the data. Not greater than bar count minus 1. So just to be sure, the maximum value that you can put in minus the min would give you the range, which would give you exactly the bucket count. No, except this is ceiling and this is floor. So it could be exactly the bucket count. If the range is divided into the precision exactly. But we'll just say that that maximum value should get pushed back one into the fold with everything else. It's basically like you have these buckets which are ranges, and the small end is inclusive and the large end is exclusive. So like everything from 0 to 1, everything but not including 1, everything from 1 to 2 but not including 2. And the last bucket has to be like everything from 9 to 10, including 9 and 10, because you're at the end, right? And someone has to include 10. I guess if you have a range where 10 is your maximum value and 0 is your minimum value, you would want 11 buckets. Let me think for a second. If I had a range of 10 and a precision of 1, this is saying we take 10 buckets, but I feel like you would actually want 11. Yeah, this is going to be in the new base layer or rather, it's one of the extensions. The base layers, I try to contain it all inside the stuff that is called Mr. Fourth Base. So I want to get that out, and then this will also come with it. Things like the ASCII stuff, the PRNG stuff, the new Magic ID and Magic Gather Array stuff. Let's see. Some of it I won't bother to include just yet. ID, Gather, Base, ASCII. That stuff will come. Some of this stuff is a little off. And so I don't know. I gotta figure out a way to publish this, to pick apart unfinished stuff from finished stuff. And I haven't really taken a minute to figure out how to make that part real. But I have it in my project binder to get the base layer that is open publicly up to date by the end of 2025. Hopefully sometime by like the halfway through the year even. Okay, if I had a range of 10.5. Okay, let me think. What is happening here? It's saying the range is the minimum value and the maximum value. I feel like you just got to add one whole one. And the reason I feel like that is there should be like a little radius around these, right? The minimum and maximum should be like history max plus half the precision, a little radius. History min plus half the precision, or minus half the precision, which if you do the math, this just adds up to adding one whole unit to the whole thing. And hist range, which only gets used there, I suppose, actually just amounts to that plus 1. Yeah, I understand. I just kind of updating you. There's no real reason. I just haven't been motivated to organize code for the base library for a little while, but I want to do it. I've been getting frustrated with me not having the instructions written in for myself at this point. This happened just today. Okay. Okay. All right, so that gives me a bucket. Then I get myself a bar. Half bucket is bar count divided by 2. We can just grab that tick there. So this bucket, the width of a bucket is a bar count. Half a bucket more gives me a bar index. I then go into the bar index and I want to update the stats on that bar. So the min, RPG, this is bar equals bars plus bar index, bar min, bar max, bar total, bar data point count plus equals 1. Good catch, thank you. Okay, so the bucket index looks like that. Bucket index times bar count plus half bucket divided by bucket count gives a bar index. Then I grab a bar, fill into some data for the bar. Then I need one of these. What this does is we're going to look at each bar, and we're looking at this doesn't actually help. Sorry, that works a little different than I thought. But that's okay, that just removes some of the work for us here. What I was thinking was min and max of the bucket counts within the bars, but I'm not keeping track of how many elements are in each bucket anymore. I was sort of thinking of it as like if there are two buckets in a bar, then I'll look at the average height of the two and the max and min height of the two, but looking at just the max and min value doesn't give you that. I would have to build things a little differently. But this is fine. What we need is the height of the bar is the total of the bar divided by we're going to change this algorithm to not escape until the last moment. We have an extra bar to fill. So at the last moment, it should fill the last bar with the bucket index that is also equal to the bucket count by doing it that way. Okay. So then what we want to do is look at the bar count, or bucket count. Something like this, number of buckets on this bar, which is bar plus 1 first bucket index minus bar first bucket index. Histogram. Okay, this can just be called max height. Max height equals max of max height and height. What if we just throw in a little bit of space this way? So we're not going to count them exactly. I mean, that could be sloppy, but I think that will work. It'll be kind of weird when it throws a -1 in on something that started at 0 before. I don't know. Maybe not. It's hard to say. Okay. Now, if we wanted to, we could throw in one other trick, which is we could either replace the total or write a new field in here that's going to be like bar height equals height, right? And we can do the max height down here instead by going... Okay, yeah, this is cool. And then we want a grid. So the grid is currently made out of the params width and params height, which is the space we have for actually filling here. And I think I'll leave it that way. I want to iterate the grid. Okay. So what we need to figure out is what's the bar height for this bar, right? Basically, we need to be able to go bar index, and for now that's just going to be x. The bar we get back is this. This can change if I end up deciding to allow bars to be wider. We actually have to be in a bar for it to matter. Then you grab a bar height. But that's not what we want. We want the bar height. We want the ASCII height or whatever, right? We want the grid height. And then to get that, we have a height from the bar times the maximum height. So this can be a value between 0 and params height. Bar height divided by max height times params height gives me a grid height. Grid height. I guess for now, I'll just do what I did before, and we'll come back around and tweak things to be better over time. Now we go from y equals 0 to the height of the grid. And this weird formula here is really saying as y gets larger, we're going down, and we want the bottom of the histogram to be where we place the stars, or the fill in the gaps, right? So if the bar has a height of 5 and the grid has a height of 10, the top 5, 0, 1, 2, 3, 4, these are spaces, and the bottom 5, 5, 6, 7, 8, 9, these are stars. And so the way I'm achieving that, it looks funny, but it's basically if y is greater than the bar height minus the bar grid height. That's what it really means. So if y has gotten larger than or equal to the amount left over when you take the maximum possible height and subtract out. Right, so this gives us the sort of the inverse. Once you get below, once y gets larger than this, you're below the top of the bar, and so you fill it in. Y, X, C. And then having the grid in hand, we're going to send it all out. But we can do better, because we can go like this: ASCII width equals params width plus 1. This is actually going to get more complicated anyways, so we might as well embrace this now. X is going to be less than params width. We do that, but we're not using params width for indexing the grid anymore. We're using ASCII width. And then in addition to everything else, at y plus ASCII width I time y plus 1 times ASCII width minus 1. Or I guess the other way to write that would be y times ASCII width plus ASCII width minus 1. And it's about the same amount either way. Let's do this version because we can go params width like that. These will just be our new lines right away. So we won't need to use format strings to create them, and we won't need to do anything except create a single node onto our... Now the grid is in ASCII, or is in Scratch. That's not going to work anymore. And then we push onto the output arena. We just push the whole grid down at once. The new lines in there and everything. Okay, so that's not right, but we got it started. Let's walk through and see what's wrong. I'm satisfied enough with the amount of progress that looks like to commit to this new path. And let's take a 5 to 10 minute break. So I can get up and stretch, because I've been at it for 3.5 hours, which is a lot for me. But I'm gonna take a 5 to 10 minute break. Actually, I'm gonna make it a little longer. I'm gonna make this a 10 to 15 minute break. And when I get back, I will get to work on fixing bugs in my ASCII histogram render printer. Okay? So I will be back shortly. See you around. Okay, I've got a little food coming. I kind of blew past lunch, not entirely, but I mean, it's been 5 hours since I ate now, 5.5. So I put a little something in, and I'll have to take another break to eat. But I'll come hang out, and if there's anyone here to chat, I might be able to interleave it or do something else for a bit while I'm catching up on that part of things. But I want to step through this. I've got like 5 minutes before the thing goes off to let me know the food is done. I want to see. This is the wrong session. There we go. Good. PRNG. Histogram. We fill out all the values. When we're done, what we have is 1,000,000 values. We can actually see 1,000,000 values in Remedy. But here we go. Alright, well, fair enough. Doesn't say a lot to me. Come on. Come on. Get me out of here. Ugh. We didn't build computers the right way. You see this? This isn't the right way to build them. Okay. So we fill up the bars. And we look here, bucket index 1, bar index 1, because 60, yeah. Since this and this are equal, this doesn't matter because it's always going to be map 1 to 1. Bar index 0. Bar index 5. I just want to keep a look take a look at what's happening with S and with bar index through this loop. I think that's the right thing to look at. Do wonder. It says here it achieves the value of 10 somewhere, which is the maximum it can ever achieve. But it doesn't achieve 0, which is interesting. Kind of makes me want to go check the PRNG float stuff. That could be super fishy. I probably have never really learned what I'm doing in that realm. Okay. So with all that, I don't get the impression that when we're done, the bars are going to be uneven. They should be uniform. There are 11 of them. The last one is always empty if everything is working correctly. Unless, of course, one little sneaker sneaks in. Gotta fix that because that's happening. Oh, yeah, this off by one stuff is going to be annoying. If I take this out, it depends on whether or not you're using an integer system or not. If I tell you that you have numbers coming in between 0 and 10 and they're real numbers, and I'm going to have you put them into buckets with precision 1, then what you would do is make 10 buckets. The values from 0 up to but not including 1 would go in the first bucket. Values from 1 up to but not including 2 would go in the second bucket. Hold on one moment while I go and grab my food, and then I'll keep explaining. Okay, so I was saying, if you're in the case where the range of numbers that you're getting data for is between 0 and 10, and it's real numbers, you would interpret, and you want a precision of 1, so a bucket width of 1, you would interpret that as meaning you need 10 buckets, right? There's the bucket from 0 to 1, the one from 1 to 2, the one from 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to 10. That's 10 buckets that covers the whole range. And you would have one bucket be special. Like the first one would have a partially open interval, and the second one would be a half open interval, and so on and so on. But the last one would include everything from 9 to 10, inclusive on both ends or something. One of the bookends has to break the rule. But that's how you would do it. If you're histogramming integers, then if the range is 0 to 10 inclusive, you need 11 buckets. I think they just need to be different. Like, I think that I need to split the logic between them, because as I'm thinking about it right now, I don't think there's any way to make it work both ways. Unless if you say, hey, when you want to do quote-unquote an integer data set, the maximum value needs to be +1, because we're sort of like saying, since you're dealing with integers, the how do I want to put this? With real numbers, the points are like infinitesimally small, but integers are like numbers that are fat, right? They take up space. So the number 10 starts at the real number 10 and lasts all the way up until 11. So 11 is the real max. I think that's the way to deal with it. And with that in mind, I think it's wrong to do this. If I have exactly a range of 10 and a precision of 1, then 10 buckets is correct. because that's like having from 0 to 10 real numbers, which is also the same thing as 0 to 9 integers, since you have to add one to the max. Okay, so there's one decision. Now, that should mean after we run the fill buckets function or block, we should be looking at 10 bars, not 11, 10, that are all roughly equal. But actually, they're not all roughly equal. And I think that's because I think I just totally forgot how to think about what a histogram does. I don't need a total either. The only way that I would ever do the min-max total thing that I was trying to do is if I first did a pass with the buckets data structure and then resolved that down to the bar resolution, which might be the right thing to do. That would let me display more, and maybe that's what I actually wanted to do but didn't quite picture it right. I didn't shake it out the ideas quite right the first time through. But I think the height here should just be the data point count divided by the number of buckets on this bar. There we go. Now there's no little funny artifact in the corner here. And if I go and look at this, so here's where I'm creating the random variable. Right now it's a uniform distribution because it's a million samples of an integer or a floating point number between 0 and 10. Right, this gives me a random between 0 and 1, and then I multiply by 10. If I add a couple of them up, then let's say we can add up to 4 of them. That'll fill out that width of 40. I should get a sort of more normal, something closer to a normal distribution, like that. Yeah. Here's the case with 20. This is more like a perfect triangle. It's like the continuous version of when you roll 2 dice, how 7 is the most likely, and then 5 and or 6 and 8 are equally likely by 1 less 36th or something like that, and then each number farther out goes down linearly and it forms a little triangle. Same thing here. If we do 3, it starts to get a tiny bit curved. If we do 100, it takes a second, and it's very normal distributed at that point. But it only fills up the first 40 bars. That's cool. Okay, so that's good, but I don't know if that is going to solve the artifacts problem because I haven't moved things around a little bit to create an artifact. So the way you would create an artifact is if the width was smaller than the total number of buckets, but they weren't clean divisors to each other. I mean, this maybe can do it. This would give you 1,000, but that would be divisible by 40, so that wouldn't have pulled out, that wouldn't have created an artifact. In order to detect an artifact, I think it'll be better if we do a slightly different kind of random variable. Let's do f32 x naught equals roll, and then x equals the max of x and x naught. So this will give us a different distribution, and it'll be maxed at 10. I'm going to actually make it be maxed at 50, and I'm going to give us a width of 30. So we'll have 30 buckets, or 50 buckets, and 30 uh, bars, like we were talking about when we were setting everything up. And I think that is the right distribution. Although, no, that's not right. You've got a width of 40 still. There we go. That's more like it. So there we go. That's the histogram part. I'm gonna hang out for a minute and eat and think about what to do next. Okay. So I think I want to go to the table system. Um, this solves the aliasing problem. Well, I guess I haven't actually even proved that part yet. I guess it does solve it. The the way you could see what it looks like when I didn't have an aliasing solution would be if we just calculated bar heights from the data point count. So each point gets mapped to a bucket, and then that gets discarded and mapped to a bar, and then we increment the bar count. Now, if we had just skipped a bucket index and mapped straight from S to a bar, it would have given the same result if, conceptually, S just maps down to a bar now. This might be adding a little bit of distortion since we first mapped to a bucket and then to a bar. But, so that's, in other words, some points which could have gone to the next bucket over will actually go to the wrong bucket, or points which kind of seem like they belong to one bar will actually end up being associated to a different bar because of this. But then to make up for that, the improvement to the situation is that it normalizes each bar based on how many buckets hit it. And if we didn't do that, it would be as if we had just counted how many things hit each bar. So if you really, really wanted to test what it looked like when the aliasing problem was there, and the reason I'm doing this, in case this is probably not clear, I'm doing this because I want to convince myself that I did solve the aliasing problem, and so I first need to produce an aliasing effect. Like, I need to see the artifact so that I know that I've got a example case, like, is my current set of data that I'm putting in capable of generating an artifact in the first place. If it's not, then it's not a test case. So I'm trying to write the code wrong, but wrong in the right way. You know what I mean? I'm trying to write it the way I had it before to make sure I solved the aliasing problem I had before. So instead of going straight to a bucket, I'll go like this. So now it just goes straight to a bar. This is all in floating point because S and history bin and precision are floating point. So that'll be floating point and that'll be floating point. So it should just give me the correct bar, no artifacts from the bucket mapping. Intermediate step, and then it'll not give me normalized bars. And so now we'll see if it can artifact the way it used to for me. Let's see. Okay. So I'm going to do an integer phenomenon now. I said I wanted to get to the table, but I'm realizing I didn't finish this. Maybe it'll be easier to see the artifacts with the integer case is what I'm thinking here. A nice uniform distribution of integer data is going to look jagged because of the artifacts. So if it's an integer histogram, we said the main difference, well, a couple of things. One, if it's an integer histogram, then precision should be an integer. Paging Turner, that's exactly right. The question is, what's the motivation for using these ASCII charts? Is it to make it convenient to run and show in the text editor? Yeah, that's exactly right. I and presumably, sorry, excuse me one sec. So presumably I would do a graphical interface for this at some point, but the the slog of building a graphical interface takes so long every time, no matter how you approach it. And there's so much stuff that I want to work on that if I keep having to build the full graphical interface from the ground up with whether it's from the ground up with a library or from the ground up with C, it's always too much. And so I'm just using whatever is sort of like the already live programming environment. I have a text editor. I want to fold my workflow into this interface that is sort of compositional with everything else that I have in this interface, right? I can bind the functions for running commands to various hotkeys and stuff. I can then run stuff, get the data, and have the code right next to it, and there can be an organic back and forth between the output and the data constructing it. It's not a live loop that's constantly running. It's not live code entirely, but it's way better than having a program that I run separate that pops up a visualization that I then look at and study, and I write stuff down, but I can't copy paste, and I can't easily tweak the layout of stuff. With ASCII, I can do it. All integrates. I do wish that it integrated into something better than text files, but this is the interface we built, and I've kind of just been like saying, as long as this is the interface I have, I need to embrace it. Obviously, my goal is to build something different, but I have a bunch of baby steps to make. So I'm just gonna learn how to build a workflow in TextLand as, you know, as practically as possible while I'm digging in to build something to replace it. Okay, the other rule is that if you are an integer histogram, then the histogram max has to be one larger. Okay. There we go. That was supposed to be uniform, I think. Oh wait, no, it's not quite, but it's still showing artifacts. There we go. So this artifact is now tracking the bias towards certain bars. You see that? This bar, both look twice as tall as this one. What's really happening is that the integers 0 and 1 land here, the integers 2 and 3 land here, the integer 4 lands here, and then the integers 5 and 6 land here. The distribution has packed some bars with more possible destination points than other bars. And so the whole point of the normalization idea here was to say instead of just adding things up in the bars, what if we'll still add up how many elements hit the bar, but we'll map everything through these buckets. And we'll be saying that when we're doing an integer histogram, the buckets will be one integer each, so that we don't have any aliasing within the buckets. And then we normalize the bars. The bars are a graphical display averaging a couple of these buckets to smooth them out. And so now uniform distributions look uniform. And cool distributions look cool and not ridiculous. This is wonderful. Okay, now I'm ready to go to the table thing. I just confirmed that the aliasing problem is solved, and I consider this done for now. Now, I didn't write down my second to-do, but I thought of one. Now I'm hoping I can remember what it was. I had one earlier while I was programming stuff. Byfask asked which version of C I'm using. I believe it's C99. Flask, hello. I don't exactly know how to answer your question. It's definitely not like the old school C where you have to declare things at the beginning of blocks, but I don't use anything like that is not compatible with C++ either. Like I don't use void pointer casting. I don't use like the magic automatic casting. I obviously hand cast it, but like I don't use the register keyword. I don't use the imaginary number stuff. I don't use any of the new C stuff. It's just basically anonymous unions and declarations after the beginning of the scope. Okay. Now let's dig into the table. So the table. Let's split this up. So this can be the histogram system, and this will be the table system. This will be the functions for the histogram system. This will be the functions for the table system. Functions histogram, functions table. Something's got to change about this, but here we go. We'll just go Okay. I'm gonna put some music back on and let's see here. Table begin is fine. Row. Every time I add a cell, if there's a row that is active, I create a cell, stick it on this row, update the column count of the table. All right. Hope that everything works out for you. Stay safe. See you later. All right, let's see here. Cell gets a string, push copy of the string onto there. All right, so you're just storing up strings that you get passed. And this runs a format and then gives you a string. So that's a format string for a single cell. This is a compound string for a cell. Until I have a streaming API, I don't think there's anything to change here. I might want to change this to being a sort of parallel set of delimiter calls together with a single stream of text later on, because that would avoid some string copying and some data fragmentation, data bloat. Okay, let me see how this stuff works. You put in a table and you want to find out the string that you get. You create an array of integers for the columns so you can count their widths. Then you print each one, right? But this part wants to change, right? I'm considering doing this with a grid again. So instead of having a sequence of format strings that have to be laid out or a bunch of nodes getting pushed on it, it would just become one giant grid again. That actually seems the way to go for purpose of performance. So the grid size in this case is going to be calculate total width. For each column, width total plus equals the column widths I. We're also introducing a space between each column automatically right now. If table column count is greater than 0, and the number of row separators equals column count minus 1. Then we need each row table row count that gives us a grid, and then the Y is always going to be based on the current Y is always going to be based on the on which row we're on in the table, and then we're going to want to make like an X cursor. We're kind of like doing string printing here, but we don't have to render it this time. We're rendering it into a grid of ASCII. So it's just a memory placement. It's not a render call at all, but it's the same basic pattern. In other words, I'm going to go I'm going to just copy this concept. The ASCII width is going to be the width total plus 1, by the way. That's because we put new lines in at the end manually or automatically. Where this code manually does it so that all the other code automatically does it. I don't know. I actually don't know how that works. What is manual? Is anything manual when you think about it? I don't know. I really don't get it. y times the ASCII width, grid line. Okay, so then what we want to do is memory copy into grid line plus x from cell string dot string with cell string dot size as the size. Memory copy, grid line, then we want to fill spaces. X plus column widths. I see. So the X where we started the column, we start column, yeah, we calculated column widths, not positions. So what'll happen is X is always the beginning of a column. Then we fill in some data. We figure out where we have to fill to. All the columns but the last one get an extra space. Maybe there's some ways we could make that a little more easily worked out. Copy the string, fill to X. That's going to be like cell string size xi is less than fill to x, xi plus equals 1, grid line xi equals space. So this does everything but fill in the spaces past the end in case there aren't enough cells. So, okay. At the end of this, x equals fill to x, right? And then you keep iterating. When you get to the end of the loop, you have to do another one, which is like, well, x, it remains less than... Well, x remains less than the, what is it, I guess the width total, because the ASCII width includes this new line, so it's like grid line x, this is x plus equals 1 all the way through now, space, and then at the very end, grid line x equals new line, right? And we could also just say like, hey, this is not even about x at this point. So this is final padding of spaces, and this is the new line. Okay. Of course, I haven't set up main to actually print any tables yet. All right, so how do I print the table when I'm done playing around with it? I don't actually have the function for that yet. Let's see, table stats f print arena string 8 list out. No, wait, sorry. Out table. F print. So, Terius Python, why don't I just tell you how I got to this particular playlist. This is just like the Spotify radio, the auto-generated, uh, and it looks like it has gotten back to the beginning of the loop since I started earlier. But I got it off of this artist. Like I just put the radio on for this artist, Byrocratic. Is that a familiar one? Because I've always really liked this album here by Byrocratic. And that's why so I just played that. I just played jam off of this, and if it hit something that is a rare niche for you, then that's how I got there. Okay, table. It's not stats f print. That's not it. Table f print. Table. Straight table. And then print the straight list. Okay, good. It needs an arena when you do the row. And that's part of the way there, but there's actually a mistake, which is I didn't finish. I filled in the grid, but I didn't do the last step, which is take the grid and send the grid out to the string list. And then of course I have to call table f print standard out table. That's not right. If I do this right, I should. Okay. So why is it all messed up? I think the best way to answer that now is the debugger. Start from here. So the width total is the column width total with the row separators. There are 4 row separators. Column count is 5. Oh yeah, that's right. So that and those are. So what do our column widths look like? We got 4 columns. Okay. Four rows and 46 characters wide. I get y times the ASCII width. That's the grid line. Six. So show me what's going on with grid line right now. We've got 46 characters here. And then we start filling in the space. And then we go to the next cell. That fills in a bunch. And we start... Ooh, that's not good. Ah, there's the mistake. Okay, I'm gonna just change something here. We fill that, and then let's just do x plus... Oh, we can't. We need to keep x. So we can calculate the fill to x. That's why it's so annoying. Okay. x plus equals cell string size. While x remains less than x fill to, we'll just increment the x to do this. Let's go. Okay, there we go. There's the basic table system. Now, with the table system, there's a lot of stuff I could imagine wanting to be able to do. For one thing, I'd love to be able to mark a cell as being, you know, left, right, or center aligned. I'd love to mark. I'd love to control the delimiters more powerfully. So like right now, it just automatically gives you a space. But what if I wanted a table? But I'm using this to display a table so important that I want like all the bells and whistles. You know, like here's the bells and whistles version of a table. It's like boom, 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 and then boom, 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 boom. You know this thing? You've seen this before, right? And then down here it's like this, and here it's like this. Then it's like this, and then it's like, okay. You know what I'm saying? Let's maybe just tap out right there. But you get the idea. Right, imagine you could auto center the header and all that good stuff. Maybe aligning a column by its period or something too, so you can say like, okay, how many, we might want to be able to declare a particular column is going to be a decimal number and therefore it needs to be aligned by the decimal point. I don't know. So I could do that. The question is, should that be just a built-in style? Should there be several different table printers with different styles? Or should that be programmable? Now, I don't always want that, right? There are other kinds of table situations where I'm putting down a matrix or something where I want a different layout, where I want something more like, you know, some controlled precision across the thing. And I'm like, show me my matrix. And it's like, here you go. Here's your matrix or whatever. So the two ways I could imagine making this work are, one, I could just say, whenever you want a new ASCII table style, you're going to come and implement it. So this is table fprint plain. This is wire boxes or whatever, you know, wireframe. This is matrix. The other way I could see doing it is by going with a kind of it's a lot of details to get through. It's a kind of 9 segment, 9 part UI layout kind of thing. Except I don't know if they're actually like. I mean, you might provide the 9 parts, but like. So this has no corner. It has no horizontal edge. It has no internal edge. It only has a left and a right side. Right, so this right here would kind of give me the different shapes I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different types of pieces. Because there are 9 types of like knots. And there are 3 types of horizontal lines and 3 types of vertical lines. And then separately, there's this question of when do you apply internal lines? So you could say you only apply it at the first one, or you apply it on all of them. And so each of these is an ASCII character, and then there's a Boolean. Or character, character, character. But then you also have use internal, every line, sep every line, or whatever is a Boolean. That might kind of give me the configuration of all the different types of tables that I want right now. I think we could do that. There is a problem though. It's not a character. Okay, this is where it gets really nasty. If this can be omitted, then it's not just that those characters are spaces, it's that the height of all of them is 0. Right? It's like there is no So then you'd end up needing a height for this, a height for this, and a height for this as parameters. And then also a width for this, and a width for this, and a width for this. So that you could say, okay, I know how many lines of text to generate for the separators. You know, it could be 1 for each. You could just say it's got to be 1 or 0, but still it's got to be specified, because like here, I mean, it's not even that simple. If there is a separator here, like this separator is 2 spaces, is 2 characters. Do you see that? It's a colon space. This, the default that I have is basically where the knots are all, there's none of the heights are 0 on each of these, the widths are 0 on this and this, and the width on this is 1, and it has a space. Man, that's gonna be just a lot of plumbing. Even if I just do allow one character at a time. I think we could go farther than this. We could also have the table know these kinds of things. Like, I could say, do a row, and then the top row would always get this, not optional. So if you don't want it, you don't specify it in the style. And then you do a row, and then you can say, like, horizontal separator, and then you do a row, do a row, do a row. Vertical separators wouldn't be they wouldn't be optional. But row separators could be. And you could just specify that on each row by saying, like, when you create the row that it's going to have a line, or after you've created the row, you can say separate or horizontal line, whatever. So that could then just be a Boolean sitting on each row. Of course, the last one has to have the bottom style. What the hey? Let's do it. Oh. Okay. Um. Okay, so the thing is I could just do a U8 if I was guaranteed it was always going to be a single ASCII character, but then these just have to be heights of 0 and 1. I could do a pointer, then it's a C string. It's a null terminated string, which I don't usually go for, but if I don't want that, then like the next step up is a string 8, and now we're moving around a big honkin' thing here. I think what I want is that it's not that they're C strings. It's that we are assuming this has been baked and correctly arranged ahead of time. There's no safety here, right? There's no runtime information to allow us to validate the stated widths and heights against the strings you specified. There's not even necessarily null terminators. We just assume the bytes are right. That's the plan. That way this part can run without any baggage. Then what we'll do is we'll build them carefully. So I'll do the careful part later. They're already going to have to be built so carefully because they're so complex that each style is going to be a little bit of a process. Okay, so you want to print a table, give it a table style. And then we're going to produce the new table according to the rules. So to give us the width of each column, good. There's the column widths total. Here's the number of row separators. We also want to know how many column separators there are. If table row count column count these aren't row separators, they're column separators. These are the row separators. Row separators is equal to table row count minus 1. So now this needs to be times the style width 1. And then we also have to add in style width 0 and style width 2. Height total is going to be the row count. So one line for each row, plus the number of row separators times the height of the internal row separator, plus the height of the top and bottom. So there's the total size. ASCII width minus height total. Table cells. Here is the top border. The top border goes for those first few rows. And we have the top, so we have not 0, 0. So we're going to memory copy into the grid line. Here, give me an x equals 0. Grid line. Style not 0, 0, the top left. We'll call that x and we'll call this, it's a little weird, but x and y. And then the amount is the width of 0. Now hold on, horizontal separators aren't strings. Those are characters. Because they create these lines here. So the not is a string that'll fill out this line here. I mean, I guess I just don't have an example of like an extremely ornate border, but like it might look something like this. So the not would be this thing, and then this would be the border. But then you could imagine making the border even fancier by doing something, I don't know, like this. So then this 4 blocks is the not 0, 0. This is the string of the horizontal separator. So these have a length equal to the height. That makes sense. Okay. Okay. Same logic as before. We set that up. The beginning of the not, the width. We grab a filler. We do x plus equals the width of 0. The filler is whichever character we need off of the horizontal separator. Then we begin a loop that says fill to x equals wherever we're at. I don't think we do this anymore. I think that's logic from when we had built-in separators. We don't have that anymore. So fill to x, then just a loop like this until we get to fill to x. Just keep filling in the filler character. And then when you get there, right. So this is one for each column. One for each column. We look ahead to the end of this cell, fill it in. Then, if column index is less than table column count, and then we have to do the top middle knot. That's the one with x1, y0. So that's going to be one zero. And so that fills in the separators. This is where spaces get accounted for down here. That extra +1 for the space. So this is the filler line. This is the filler knot, the 1 0 knot. And then there's a bottom. So the last one, when column index +1 was there, it didn't get to finish filling in because we don't want to fill in that way. We want to fill in like this. Not bottom, this is right. So X up to there. And now if that did everything right, this plus this plus that many width ones plus all of the column widths should be total width. Width total. And then grid line X equals new line, and there you go. You do that for each line of the top border. Then to start printing table cells, you do the same thing. Okay, index is now known to be row index. Sorry, column index. I can't get that straight. And so what we do here is left okay, this isn't actually everything. What I'm missing here is when I access one of these knots, it's a string of a pattern. So if this was a 2x2 space, then I'd be accessing the top part of the pattern each time. What I actually need to do is then access the string plus y times this width. That's what I need. Left, middle, and then here we're at another knot. Left, middle, right. So this should also be plus y times style width 2, I take it. And this should be plus y times style width 1. So this works. This is achieving the result by just scanning across each character in the output one at a time, left to right, top to bottom. We could go for more of a rasterized style approach where I could just say like put down the 4 corner knots automatically, run filler across the whole thing, and then overlap the filler with some of these like render in the internal knots. Like I could set it up like a renderer if I wanted to get real if I really wanted to make it expressive and less mind bendy. But doing it this way might be good enough, and might make it, I don't know, faster, or it might not. It might actually be a lot slower this way. I'm not sure, but it's like it's not every day that you can make it click in your head like this. I think if this is gonna work, it feels like it's gonna work, and I think I should just keep going with this, even though it might have been better to do like a render approach. Okay, so now we've done the top border. What happens next is we start rendering table cells. To render a table cell, we go left, y of 1. There's no knots involved in rendering this, actually. This is going to come from vertical separator 0, the left side, which has a width of 0 and increments x by that much. So that's the left side. And then there's the middle. And in the middle, you fill in a string, then you fill the rest out to spaces. So you put in a left side, and then you put in a middle, which is a cell, which is analogous to the filler part. And then this is what's got to change. So this is how we used to figure out, right? This is if column index plus 1 is less than table count. We're not just filling one space farther, we're actually copying into the grid line X at that spot from the vertical separator at position 1 with width 1. And then we don't need a padding. Well, let's see here. How do I want to do this? I'm going to have to rewrite this for loop like this. And I'm going to take the cell out and say cell equal, well, we'll do it this way. If cell does not equal 0, do all this stuff, and cell equals cell next. So then all of this is everything else you do. You increment the cell, but up here you're just doing the fill to X logic on the cell, right? But you're incrementing by column index, or you're going by column indexes now, so that this part and this part can happen every time. The cell part just goes here and fills in the cells while it can, but if it runs out of cell data, it still lays everything else out. We don't need to fill to the end anymore. And then we need a right-hand side, which is not going to be a not. It's going to be a vertical separator at position 2 with width 2. And then we're done. So that's how you do a row of the table. Then I don't know, something like this. And then this is going to look more like this. It's a horizontal separator. The only difference between this and the first one is that we're now looking at the case where y is 1. And all of these. And so what happens there is we do a row, and then we do y plus equals 1. And then we do this loop here to visit each line of the horizontal separator. And increment y further. And that's great, but you only do that if row next does not equal 0. You don't do that on the last one. And then, once you've filled in all the table data, there's one last step, which is the bottom border. I think a lot of that can be deduplicated into a little helper without too much trouble. Okay, we're going to deal with that later. So this isn't done. This is the wrong horizontal separator because we are dealing with y of 1 here. All right, now I'm gonna go just manually craft a table style to get this started. So plain style will be the one I already had. If I can recreate that, then I will be happy that I didn't wreck it. Plain style, if I set everything to have a width and height of 0, then I won't have to worry about too much. But I do want a width in the internal separators of 1. Now, since all the heights are 0, the knots are all still empty. But the vertical separators in position 1 now needs to contain something like this. And okay, so there's plain style. Now let's try wire style. This one's more work to set up. Let's see what we got here. Wire style dot width 0 equals 1, width 1 equals 1, width 2 equals 1. No, sorry, width 0 equals 2, width 1 equals 3, width 2 equals 2. Wire style width height is all 1s. Wire style dot not ij is equal to a u8 of the plus So that sets our knots. But we're not done. The wire style, they're all going to have to get filled here. The wire style horizontal separators are all very easy. They all look like this. Now the vertical separators. Oh, you know what? These knots don't work. That's fine. All right, let's do the knots. Let's do the knots one by one here. Knots 0, 0 is plus dash. 0, 1 is dash plus dash, and 2 is dash plus. That's why it's 2, 3, 2 up here. Now the ones in the middle and the ones in the bottom all look the same. So maybe I can at least do but the vertical separators will need to be done by hand for the same reason. They look like that, that, and that. Show me wire style. Okay. That's actually way closer than I would have expected. But yeah, something's off. What are these? Those are knots. So the knots after the first line aren't coming out right. Let's take a look at what that might mean. Is it something about these 0, 1, 2? So it's possible it's this iteration somehow and I'm missing the way. But the heights, yeah, those all worked. It looks more like, I mean, that should be the same knot every time, but it's changing. It looks like it's just a pointer to some nonsense. The sizes are right. I wonder if this is like, it's not temporary, is it? I don't think that's how these things work. So let's take a good look here. When x is 0, everything's working fine. When x becomes 1, or when y becomes 1, then things are busted. The widths are correct. Oh, but we don't want to use y. We want to use I, because y is now going to be some just large number, right? You know what I'm saying? So yeah, none of this makes direct reference to the y value after we get the grid line. That's the way it has to be done. So these are actually wrong, even though they give the right result for now, because they're perpetuating a bad sequence of bytes that I don't want to accidentally copy and paste. And these ones are also super wrong. There we go. Now, I want to do the thing I said about controlling how many of these horizontal separators get placed from the row. So I'm going to go table row, table, horizontal separator, and then the way that'll work is a row has horizontal separator, starts off null, row cell, so Mr. Fourth symbol void table horizontal separator, looks like that, table row, table horizontal separator just means you go and grab the last row, the one you're currently modifying, and you said it has horizontal separator equals 1. And then I want to see, when I go to print it, the number of row separators isn't a calculation, it's a count. Doesn't count if you put it on the last one. The last one is a special case. It gets ignored. Row separator count. So now you only do this if row is not, next is not 0 and the row has a horizontal separator. Okay. And for completeness sake, I was talking about doing a matrix style as well. So internally it'll look like that, but it'll also have edges. So it'll go boom, boom, boom. Show me matrix style. Whoops. There we go. Cool. Okay, I think I'm satisfied. So now I want to pull these out as like literals, I guess. It's kind of a pain in the butt. So there's a couple ways I could do it. I could do make a compile time symbol for table plain style, table style, and then it's just a matter of mapping this, restating this without the convenience of procedural construction. Table plain style. Nice. Table wire style. No for loops. Here we go. Just Iron Man it. Heights are 1, 1, and 1. Widths are 2, 3, and 2. Knots. The knots, X. The first one you index. Okay, now I gotta figure out which one is X and which one is Y. So the second one you index is Y. So if Y is the same across these, then this is when X is 0. X is the first thing you index. So all of these are gonna be plus, minus, plus. These are the left side knots. These are the interior knots. And these are the right side knots. The horizontal separators are all gonna look like this. And the vertical separators look like this. Let's keep the old wire style. Table wire style. Okay, that's good. And one last time, table matrix style. Here we have heights of 0, width of 2, 1, 2, knots of 0, horizontal separators of 0, and these are these things. More of a simple one again. Cool. All right, so table styles are done. I think, yeah, I've been streaming for almost 6 hours now. I think now's a good time for me to stop. I kind of did my whole day in one big stream instead of breaking it up, and well, it's a good time to stop. But this was, like I said, something I was really getting pumped about getting to touch, is the cool ASCII printing stuff. I think there's still more to do. There's like stuff off the table that's not finished. I haven't looked at the indent stuff, and there's a whole separate part of this, which is how I want to replace the string 8 list that I haven't even started touching yet, but I kind of want to do a high performance data structure. So maybe tomorrow or Friday, whichever day I end up streaming this again this week, I will probably tackle the high performance string streaming stuff and spend a whole day on that. But yeah, this is cool. So I've got the printing stuff started up here in the base layer, so I should be able to use this in any project I work on from now on. That's going to be great because I want to go back and redo the object file dumpers. I'm kind of abandoning bin dash for now and instead just going to go with dumpers because I think that I have too many things to do with object files to be stuck on a big complicated graphics application problem. And so I'm gonna use this for that. I'm also gonna use it for the new RPG simulator, and like I was showing off at the very beginning, the code base already has well, let me show it here. The code base already has custom printing stuff. I've been thinking it would be cool to add in is there, yeah, it doesn't say. I'm going to put this in here. M4 printf pluggable M4F printf programming, so that you could, for a given program, modify the behavior of M4 printf and straight push f, etc. You could add new format specifiers that would go through and my whole code base for a specific program. And I want that mainly because I always find myself developing these cool data structures and then wishing I could just splat them on the screen, and then having to intermix simple expressions like format strings with complex function calls, passing string lists and parameter bundles of different kinds around. If I could just say, hey, in the middle of a format string, expand using this custom print rule for this particular engine, without having to intrusively modify the printf code at all, then a lot of that I could start to take another layer of cruft off the worst of that problem. So that's something I want to get to sometime soon too. It's also going to help with the object file stuff if that works out. This is not too hard, but that's just an easy candy one to get sometime. Am I missing any other thoughts that I really cared about? So something I don't have an answer for yet, but that I think will come together if I do the string stream optimization stuff, is right now, well, I can show you this way. We have this histogram thing. It'd be really cool, in my opinion, to be able to put a title on the histogram and labels and stuff like that. So let me see. Something like that. It would be cool to be able to put these on to the histogram, and it might be easier to do that if it could work off of a table system. That's what I think sometimes. Like, it might be cool to be able to create a histogram and then throw it into a table with a label. I don't know, maybe not, because that starts to sound more like a spreadsheet where you got like cells that can merge and then break out more cells underneath. Lining up the labels is going to actually be kind of weird and hard. But I already give it a range that's the rectangle for the histogram and control that. So if I wanted to place the whole histogram inside a larger thing and say, like, okay, we're going to shape it like this and put down a title here and some labels here and here on the edge, and then the histogram goes in this section, I think we could make that work. That brings up the question of, like, how do I lay that all out? And I think that's where I'm thinking a table is necessary. But actually, even as I'm saying that, I realize the table doesn't support new lines. New lines in cells. So I couldn't do it very easily yet. The thing that I don't have is I don't have any way to like, if I didn't do this with the table. So I could do it with the table. The other thing I could do though is some kind of like, and this is what I was saying before, I could take a sort of render approach. Place would let me place small grids within bigger grids. Like the histogram within the larger histogram diagram. Okay, I think that's good for now. Yeah, cool. Cool. So I'm going to wrap up here for today. Like I said, probably going to stream on this stuff, probably this one, either Thursday or Friday. So if you're seeing this now and you'd like to catch that, that's when that's coming up. And with that, I will sign off and see y'all around the internet. Bye.